we've got our A and our B. I'm going to write down the formula. This is difference again, so it's going to be A minus B, right? Same sign as you started with. A squared, opposite sign, A and B together, always positive, B squared. Now notice in this formula, because I used SOAP to help me with the signs, you don't have to worry about the fact that this is a -1 or a -1 here. That has no bearing as long as you can remember SOAP. Okay, fill in my pieces. Instead of A, I'm going to put 2y. I'll put this guy in parentheses so when we fill in the B it doesn't look confusing. Okay, and then we're going to put in our B, which was 1. And there's my stupid drag marks from my fingers. And then this guy is 1 also. Okay, and then we put in the other pieces. This is a minus. That's a plus and a plus. Parentheses here, and here, and here. Then this is squared, and this is squared. Okay, so our final answer would be 2y minus 1, parentheses, wait a minute. A is 2y, it's the whole thing, and it says it's squared right here. So technically, it should be the 2 and the y, right? A is 2y. So the 2 should be squared, 4, and then y should be squared, so y squared. Plus 2y times 1, that's just 2y, plus 1 squared, which is 1. Okay, is that my final answer? Wait a minute, back up. What about this guy? This is our GCF, right? He's like the kid in the back seat. He's back there. We've taken care of him, thrown him in the back, but you cannot forget him in your final answer. So that would be that completely factored. Okay, sum and difference of cubes. The next one we still have to talk about is called quadratic in form. This quadratic in form means it looks like a quadratic trinomial or a quadratic binomial. It just has a slight difference. For example, this problem over here looks like that. But if it was x squared plus 6x plus 8, you would go, oh, leading coefficient is 1, so I'm going to do a double bubble. Got our x here multiplying to 8, adding to 6. Oh, that's 2 and 4. So it would be x plus 2, because we're looking for a plus in the middle, and an x plus 4. And that one would be factored. Quadratic in form just means instead of a 2 here, it's going to be some even number. Even number. And if this middle term is exactly half of that number, then it's considered quadratic in form, which means it factors exactly the same way. So it's still going to have the same numbers, still going to be a 2 and a 4. So an x, a 2, an x, a 4, a plus, and a plus. The only difference is that the powers inside here are now going to be half of that guy. You've got to have x to the 4th. The only way to get that is if you put 2 in the first one and 2 in the second one. Another way of looking at it is it matches this power. And that's it. That's what quadratic in form means. Now, after you factor quadratic in form, you have to look to see if you factor further. So our final answer for this was x squared plus 2 and x squared plus 4. X squared plus 2. It's 2 terms, but there's no minus, so it's not the difference of squares. Is it cubed? Because we could have the sum of cubes. Nope, no cubes, so that one doesn't factor further. X squared plus 4. X squared and 4 are both perfect squares, but there's no minus in between, so we would say, oh, you're done. So very simple. Factor just like it's a regular old quadratic. Do your x, do your cloud, whatever it takes. And then all you got to do is change the power to half of whatever that beginning power is. It will always match the middle power. So my answer for this one right here, no matter what I figure out my numbers to be, it's going to have an x and an x, and since this is squared, both of these are also going to be squared. Then it's just a matter of finding the numbers. So if I look at -4, I need to multiply to -4, but add to -3. Okay, that's going to be a +1 and a -4. So inside here, that'll be a +1 and a -4. So this quadratic in form factored into those binomials, x squared plus 1 and x squared minus 4. Don't forget to factor more if possible. So I'm going to check each one of those out. Look at this first one. I said, okay, there's two terms. Is there a minus in between? No, it's not going to be difference of squares. There's two terms. There's a plus, so I would look for perfect cubes. It's x squared, so that one's not going to factor any further. Okay, looking at this next one right here, x squared minus 4. Now I've got x squared, and I've got a minus. It's two terms, so I'm going to check. You don't need to write these steps if you know this. Square root of x squared is x. Square root of 4 is 2. So it's going to factor into the twins. X and a 2, x and a 2. They're not identical. One's plus and one's minus. So that replaces the x squared minus 4. And there you go. That is completely factored. Quadratic in form. That's it. You see a trinomial, but it looks a little bit different because of the power up there. Then you're going to have to picture it as a normal quadratic. Factor it like normal, but then change the power. It'll always match that middle term. That's the key to these. And then look to see if it factors more. Okay, here's two examples for us. All right, I'm looking through it. I'm going to save us a little bit of time. This one right here does not have a GCF. Okay, that was my first step. No GCF. Then I said, oh, it's two terms, and it's a minus. So I'm going to look for perfect squares. Square root, square root. This one right here, the square root of 81 is 9. The square root of x to the 4th is x squared. The square root of 1 is 1. It is a difference of squares, so it's the twins, but they are not identical. Okay, step 1 done. Now I need to see if it factors further. Remember, that's always your last step. So looking at this guy right here, I've got two terms. Is there a minus in between? No. Okay, it's not the difference of squares. Is it cubed? No, it's x squared, so obviously it's not cubed, which means this guy is going to stay exactly as is. All right, looking at this one, two terms. There is a minus in between, so I'm going to look for square roots. So I would say square root of 9x squared and the square root of 1. Square root of 9 is 3. Square root of x squared is x. Square root of 1 is 1. Twins. But they are not identical because one's plus and one's minus. And then this guy stayed exactly the same. And that's it. So it's this repetitive process of always looking again for a little bit more, but follow that factoring completely setup that I gave you, this thing at the very beginning. This is the easiest way to remember how to factor. Look for GCF always. Count the number of terms, follow whichever group it falls into, and then always see if your answer can factor further. That is key in this. You've got to remember to do that. Okay, moving on. This one right here, okay? Looking at it, factor completely. My first step is to find a GCF. Now, I don't want to break everything down step by step. Oops. So I'm going to let you know that the GCF is 4, which would leave 4x to the 4th plus 13x squared plus 3. All I did was factor out the GCF. I didn't write all the numbers out to the side and circle the same and all that stuff, but that's something you could work out on your own. So GCF of 4, pulled that guy out. Now I'm looking at what's left over. I counted it, and there are 3 terms. 3 terms. All right. Handy dandy reference sheet says 3 terms. It's either going to be an a equals 1, an a greater than 1, or it could be quadratic in form. Now remember, quadratic in form is when it looks like a regular quadratic, but it's got a number here that's not 2. That's p. It's got to be an even number. And this right here is half of that number. And then we know that we can factor it. Same thing down here. Okay, so we've got to figure out this as if, I'm going to pretend, this isn't the correct answer, but I'm going to pretend that it's just a regular old quadratic. So we're going to pretend for a minute that this is the actual problem. Whoops, that's just a 2. At regular old quadratic, it would look like this. Okay, then I'm going to have to do the cloud method. So I'm going to skip ahead and show you the cloud method. Okay, I fast forwarded into the future to after I have the cloud done, right? Don't forget, this is how the cloud works. Multiply, right? It joins into the, with a 3, makes a 12, factor that, easy double bubble. Have to divide that 4 back out. Any denominators get moved back out in front. Now, here's the difference when it's quadratic in form. You are now going to take, sorry, can't remember what color. You're going to take the power and change it to this guy. Quadratic in form, that's the only difference. It might look like a regular old trinomial, so factor it like a trinomial. Get it down to these basic factors, and then all you do is change the power on the x. Instead of just 4x, it's actually 4x squared. Instead of x plus 3, it's x squared plus 3. Then we would check to see if it factored any further. 2 terms in this first one, it's not a minus, so it's not difference of squares. It's a plus, but it's not the sum of cubes because it's not raised to a 3rd power. Same with the second one, so nothing else factors. Am I done? Wait a minute. At the very beginning, we had this GCF, the kid in the back seat. Don't forget him. He's still back there. And that would be our final answer.